This problem says calculate the E field at points 1, 2, and 3, giving your answer in component form. And we're given this figure. So in our figure, we have a positive charge of 10 nanocoulombs. We have our y distance to point 1 is 3 centimeters, and our x distance to point 3 is 4 centimeters. So we're given that Q is equal to 10 nanocoulombs, and that's equal to 10 times 10 to the negative 9 coulombs. Our x is equal to 4 centimeters, which we'll write as 0.04 meters, and our y is equal to 3 centimeters, which is 0.03 meters. And so we want to find E at point 1, 2, and 3. So we'll start with E1. So for E1, we're looking at this position right here. And so just drawing our electric field at this point, our electric field points away from the charge in the positive y direction. So this is going to be my E1. So I'm expecting this will point in the y direction. At point 3, my electric field is going to point away from the charge. So again, I'm going to have another field here, and this is going to be my E3. And then at 2, my field's going to point away. So I'll move this label. It's going to point away, and so it's going to be something like that. And I would expect that that this arrow is smaller than this arrow, and that this arrow is even smaller than both of them. Just because this distance here is smaller than this distance, and the hypotenuse of my triangle is smaller than both of these. So for E1, the equation is KQ over R squared again. And so plugging in, I have 9 times 10 to the 9th Newton meter per coulomb squared times Q, which is 10 times 10 to the negative 9 coulombs, divided by 0.03 meters squared. And plugging that into my calculator, I get 1 times 10 to the 5th Newton per coulomb. And so E1 is equal to 1 times 10 to the 5th Newton per coulomb. It's a vector, points in the positive y direction, so I'm going to put a y hat next to it. So now we have E2 is equal to, again, KQ over R squared is equal to 9 times 10 to the 9th Newton meter per coulomb squared times 10 times 10 to the negative 9 coulombs over 0.04 meters squared. And here I get 5.6 times 10 to the 5th newtons per coulomb. So E2 is going to equal 5.6 times 10 to the 5th newtons per coulomb. And here, sorry, this was 3, a little out of order. And so that is this arrow right up here. That's this arrow. So I know that I'm going to be pointing in this is an arrow, and it's going to be pointing in the x hat direction. And then for E2, I'm going to have KQ over R squared again. That's going to equal 9 times 10 to the 9th Newton meter per coulomb squared times 10 times 10 to the negative 9 coulombs. And now my length here, my R, is going to be the hypotenuse of this triangle. And so I know, drawing this hypotenuse, that this is, if this side is 3, it matches because of this side, the 3 centimeters, and this side is 4, then this side is going to be 5 centimeters. If I don't know, then if I don't have an easy triangle like that, then I can just do the square root of 4 squared plus 3 squared will give me the hypotenuse. But this one's easy, so we'll use it. So this is going to be 0.05 meters squared. And so this is equal to 3.6 times 10 to the 4th newtons per coulomb. And that makes sense, right? So I assumed that my E1 was going to be the biggest, my E3 was going to be my second biggest, and my E2 was going to be my third biggest because of the distance away that the charge is, or that the point of interest is from the charge. So now I have to break this into components. So the problem says to express my answers in component form. So I'm going to draw a little, my triangle right here. And I'm going to put this as 3, 4, and 5, and I want to find this angle. So I'm going to use the lengths to find the angle here, and then that way I can find the components of my E field for 2 using that angle. So I know that tan of theta is equal to 3 over 4. So when I plug that into my calculator for arctangent, I get theta is equal to 37 degrees. And so then I'm going to draw another triangle. And this is my forced triangle. So I'm going to have Fy, Fx, and this is F. So here I know that my Fx, if this is my angle, is going to be F times cosine theta, and my Fy is going to be F sine theta. And so that's how I'm going to find my values for, so E2x is equal to E2, I'm sorry, this should be my E triangle, not my F triangle. There we go. And so I'm going to have E cosine theta, which is 3.6 times 10 to the 4th newtons per coulomb times cosine of 37 degrees. And so I get an answer of 2.9 times 10 to the 4th newtons per coulomb. And E2y is equal to E sine theta, which is 3.6 times 10 to the 4th newtons per coulomb times sine of 37 degrees, which is 2.2 times 10 to the 4th newtons per coulomb. So E2 is equal to 2.9 times 10 to the 4th in the x hat direction, plus 2.2 times 10 to the 4th in the y hat direction, and the units are newtons per coulomb. So here's my E3, here's my E2, and we have my E1.